Alright, Cassie, this is the problem we were working on the other day with the force and work done on an object on an inclined plane. We were asked to, one, find the work done by the person. We were asked to find the work done by gravity. And we were asked to find the work done by friction. Here's what we were given. We were told that we had a cart that was fully loaded and that its mass was 401 kilograms. Okay? We were told that it was on an inclined plane and the angle to the ground of the inclined plane was 4.27 degrees. We were told that this mass was being pulled by a person with by a force of 3.70 times 10 to the second newtons, and that the rope's angle to the ground was 13.1 degrees. We were also told that the length of the ramp right here, or the hypotenuse of this triangle, was 153 meters. And then we were also told that mu, the coefficient of friction, was 0.0173. First, I want to go over here to some formulas that I've given. Force equals mass times acceleration. Now, if you'll go over here, you'll see that I've drawn a line straight down, and it's not information that was given in the question. Gravity acts on everything, and gravity is a force. And when the force, gravity accelerates at 9.81 meters per second squared. Alright? And it is acting on this 401 kilogram cart. Okay? So that is our mass times acceleration, which gives us weight. And weight is a force. And weight is a force. Sorry, we'll be using this. Okay. Let's get started. First of all, we were told to show the work done by the person. Okay? Now, if you'll see over here, I have shown that work equals force times displacement. Well, that's the simple, but it only works if you're on flat ground and you are pulling that box parallel to the ground in a straight line. We are not doing that, however. We have angles. So, the work for what we're doing will be force times displacement times the cosine of theta. And for this, the theta is the degree of the rope to the ground. Alright? So all we have to do is plug in our numbers. Okay? So we have our force, which is 3.70 times 10 to the second newtons. Now I have written it down here as 370, and I'll get to that later. Okay, we are looking at our displacement, which is 153 meters. That's how much it's going to be moved. So we put the 153 down here, and then multiply that by the cosine of our rope angle to the ground, 13.1. And when you do that, you should come out with 55136.8. Now, here's where that scientific notation is important. If you look at it this way, 370 has 3 significant digits. 153 has 3 significant digits, and 13.1 has 3 significant digits. But since it was written in scientific notation, that is their way of telling you that the force only has 2 significant digits, not 3. So when we come down here, we got to round it to 2 significant digits, which will be our 5 and our 5, and the 1 rounds down. So our answer would be 55,000. Now, it was asked to do the work by friction, the work done by friction, and here I have the formula for that. It is negative mu, and mu is our coefficient of friction, 0.0173, times the mass, our 401 kilograms, times gravity, which is our 9.81 meters per second squared, okay, times displacement, which is 153 meters, times the cosine of theta. And now this will be our theta, the 4.27, okay? So if you go down here and you plug it all in, you got your negative and then your coefficient of friction, 0.0173, times your mass, 401 kilograms, times the acceleration of gravity, 9.81, times your displacement, 153 meters, times the cosine of our theta, which is 4.27. And whenever you do all that, you should end up with negative 10372.9. However, we have 1, 2, 3 significant digits, 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 and 1, 2, 3 significant digits. So we got to round this to 3. Okay, so we got our 1, 2, 3, and then the 7 will round it up. So we have negative 10400. Now remember, friction is always negative. It is always a resistance to us. It's always a drag. Okay? As we try and pull this way, it's trying to stop us and grinding us down going that way. So that's why it's actually part of the equation. Friction is always negative. Now we were asked to find the work done by gravity. Okay, and the formula for this is mass times gravity times height. Now they didn't give us height, okay, but they gave us a way to figure height out. And height is displacement times sine theta, okay? So we're doing our sine right here, sine of 4.27, and we're going to multiply it by our displacement, which is 153 meters, and that will give us a height of roughly 11.39 meters. And so we just plug it in. We have our mass, the 401, we have our gravity, the 9.81, and now we have our height, the 1.39. And when you multiply that out, you'll have 44813, but you will have 1, 2, 3, 1, 2, 3, 1, 2, 3, 4 significant digits, so we got to round it to 3. So we got our 4, or 4 and 8, and then it'll round down. So we get 44800. Now I have put a negative in front of this. Now the work of gravity is not always negative. It's negative in this case, but it's not always negative. And here's example why. Pretend this was a round rock on this plane. Well, gravity would make it naturally want to roll down the hill, right? But we're trying to pull this cart up the hill. So we're going this way, gravity is pulling it that way, so it's a negative force for us. That's not always the case. If we were here and we were pushing it downhill, then it would be positive because we would be working with gravity. Gravity would be pulling it this way, we would be pushing it that way as well. And that's going to be positive. But for this case, it's negative. Okay? In the next vid, we will deal with that projectile problem, double kinematic projectile problem of the stone launched off the cliff and into the sea. Okay? Hope this helps.